Okay, now let's consider some other limits that involve infinity. Here we're looking at the graph of y equals 1 over x minus 1 and thinking about what happens as x approaches 1 from the right and as x approaches 1 from the left. You'll notice as x gets closer and closer to 1 from the right that your y values get larger and larger and larger. And as x approaches 1 from the left, your y values get smaller and smaller and smaller. So we can say that the limit as x approaches 1 from the right of 1 over x minus 1 is infinity. And the limit as x approaches 1 from the left of 1 over x minus 1 is negative infinity. Now this is not saying that that limit exists, or that infinity or negative infinity, that those are numbers. It's just saying that the limit does not exist because 1 over x minus 1 becomes arbitrarily large as it approaches it from the left, and arbitrarily small as it approaches from the, or arbitrarily large as it approaches from the right, and arbitrarily small as it approaches from the left. Okay, here is another graph that we can look at. The graph of y equals 1 over x squared. As we approach 0 either from the left or from the right, you'll notice that the y values approach positive infinity. That means that the limit as x approaches 0 of 1 over x squared is positive infinity. Again, this doesn't mean that infinity is a number. It just tells us that as our x's approach 0, our y's become infinitely large. Remember that we call those lines that our graph approaches vertical asymptotes. Now let's define a vertical asymptote. It's a line, x equals a, is a vertical asymptote of a graph of a function, y equals f of x, if either the limit as x approaches a from the left or the right is either positive or negative infinity. Now let's consider this graph, the graph of y equals x plus 3 divided by x plus 2. You can see drawn here both the vertical and the horizontal asymptotes. Y equals 1 is a horizontal asymptote because as we take the limit as x approaches infinity of x plus 3 divided by x plus 2, and we think about the largest variable term, the one with the largest exponent, which is x, then we can take and divide every term by x. So on top we'll have x divided by x plus 3 divided by x, and on the bottom of our fraction, or in the denominator, we'll have x divided by x plus 2 divided by x. When we simplify that, the limit as x approaches infinity of 1 plus 3 over x divided by 1 plus 2 over x. Remember that 3 over x and 2 over x will both approach 0, so we'll have 1 plus 0 over 1 plus 0, which is going to give us 1. That's why the horizontal asymptote is y equals 1. Remember that the vertical asymptote is x equals negative 2, because if you think about your function, the value that you cannot have in the denominator of your function is negative 2. If we plug in negative 2, we'll have negative 2 plus 2, which gives us 0 in the denominator. Some other graphs that you need to remember that have asymptotes, a couple of graphs from trigonometry are the graphs of y equals secant x and the graph of y equals tangent x. Now these are not the only two. Y equals cosecant x and y equals cotangent x also have infinitely many vertical asymptotes. Remember, the reason is that secant x is actually 1 divided by cosine x. So everywhere that cosine x is 0, you will have a vertical asymptote. Tangent x is actually sine x divided by cosine x. So again, everywhere that cosine x is 0, you will have a vertical asymptote.